So, was everything good before 45? I mean, I'm sure you all went home, you tried it, you're nearly done with 1.5. Is that right, Brendan? You're almost done with 1.5? Yeah. All right, fabulous. Okay. Okay, let's take a look at 45. It says, inscription rock rises almost straight upward from the valley floor. From one point, the angle of elevation. Well, let's go ahead and draw this. We've got a valley floor. We've got this big rock. It says it rises almost straight out of the ground. From one point, the angle of elevation to the top of the rock is 16.7. So let's draw this angle of elevation. So we're looking up at the top. It's 16.7 degrees. And then it says from a point 168 meters closer to the rock, the angle of elevation to the top of the rock is 24.1. So if we go 168 meters closer and then look up and measure the angle of elevation, it's 24.1. And it says, how high is inscription rock? Round to the nearest tenth of a meter. So we want to know, I'm going to get rid of this right here, we want to know how tall this is right here. Good? Okay. Where have we seen something like this before? Yeah, it's example 8, right? So let's come back here and let's make sure we understand how this one works. We'll solve this one. We'll actually finish this one off, maybe 2 different ways depending on time, and then we'll go back to 45 and take a look at that one. Okay, but again, let me emphasize, I'm not going to finish 45. We'll get started on it and see if we can get you really close. But all that stuff we've studied in chapter 1 so far, this is all going to come to a head a week from yesterday. That's when we've got the test. Okay? So if you've got questions, today is office hours. Now's your time to get help. We're going to be done here by about 25 after. Okay? So if you need some help in that time, please ask. If you need some help after that time, please ask. But whatever you do, okay, it's going to hit the fan on next Wednesday. So make sure you're ready for that. Get that stuff memorized, get it understood, get your questions answered. So this problem was set up almost identical, except for we're talking about a water tower. Again, we had 2 measures of angle of elevation, one closer to the tower than the other. We had 19.9 degrees, 21.8 degrees, and 50 feet in between them. So we took this and we looked at the outside rectangle, the big one, drew it right here. And then we looked at the smaller rectangle, this one right here, and we drew it right there. Okay, we transferred those down here into equations. So we said, you know what? If I've got to come up with an equation that relates this angle with these sides, because this is the opposite side and this is the adjacent, I'm going to use the tangent ratio. So the tangent of 19.9 degrees should be y over x plus 50. And the tangent of 21.8 should be y over x. So I have these 2 equations right here. And then at this point, what we did is we reminded ourselves, you know what? I don't even have to think about this story problem anymore. I don't have to realize that this is a trig problem or a story problem or anything like that. At this point, this is just a set of equations. It's a system of equations. I have 2 equations, this one and this one, with 2 variables in them, x and y. Now, this is ugly, but what is this? Is it a number or a variable? It's just a number. Okay? You can plug it into your calculator. You could use a decimal for it if you want. So I gave a numeric example, something that looks a little bit better. If this were just the plain old number 7 and we had y over x plus 50, and this were 9 equals y over x, how could I solve this? Yeah, substitution. Solve one for one of the variables and then plug into the other one. So that's solving by substitution. So on this one, we took this one and we solved this for x. So we multiplied both sides by x and divided by the tangent of 28. And then I moved that over there and I can use that to solve for y. Okay, now I'm going to go ahead and do that if it's all right. And let's see what we end up with. And then we'll see if we can solve it another way and see which way is easier. Okay, because we want to know what y is. Is everybody listening? If I solve for x and plug that in here, that's going to give me tangent 19.9 degrees equals y over tangent 21.8 plus 50. How many variables are in this red equation? Only one. It's y. It's the one I'm looking for. So this is like solving for y directly. Okay? I'm just getting an equation with y's in it and going for broke. I want to figure out what y is. Okay? So if I were going to solve this one here, let's see, that's a bit of a mess. I got a y up here. I got a y down here. It's divided by the tangent of 21.8. Any ideas?
Would you multiply the denominator to the other side?
Sure, I would. Okay, let's take this entire quantity, and then you could think of this like a proportion, like cross products. I can multiply these two together and these two together, or you could just simply think, I'm going to multiply both sides by y over tangent 21.8 plus 50. Okay? In either case, you're going to end up with this, y over tangent 21.8 plus 50 times tangent 19.9 equals y. Is that okay? Next. Distribute. This is just a number, remember, so I'm going to distribute it through. So this is going to be tangent 19.9 over tangent 21.8 times y plus 50 tangent 19.9 equals y. The goal in solving this equation is to get the variable on one side by itself, right? So we can read off what the answer is. Okay, so what do I need to do next? How would you simplify this? What's that? You could use a calculator. You could turn it into a decimal, okay? I don't want to do that yet, though. Okay, you could, if you want to do that, could.
Would you subtract it from the other side?
Sure. This would be like, okay, let me give you an example. This would be like having 2y plus 50 equals y. If I were going to solve that, I'd just move the 2y to the other side, right? So let's do the same type of thing. So if we move that to the other side, that's going to leave 50 tangent 19.9 on this side, and I'm going to have a y minus tangent 19.9 over tangent 21.8 times y. Now what?
Take the y out.
Very good. Take the y out. Okay, that's another way of saying we're going to factor the y out. It looks like there are two y's over here. The way I make it look like there's only one is I take that out. Whoops. Tangent 19.9 over tangent 21.8. Now, why would I leave this other ugly expression here? Why wouldn't I type that into a calculator? Why keep writing tangent 19.9 over tangent 21.8? Why would this maybe be better? There are a couple reasons. Can you give me one? Yeah.
You want to keep the answer as accurate as possible.
Very good. Okay, that would be the main reason. Okay, one of the two main reasons is to keep things accurate. The minute you throw it in your calculator, you're going to be tempted to. It's going to be 10 decimals long. You're going to be tempted to lop a couple of those off. Anytime you do that, you lose some accuracy. This is exactly correct at this point. Okay, so we don't lose any accuracy. The other thing is, I mean, if you wrote down 10 decimal numbers, that's about the same as writing down, what am I writing down? 10 numbers there? And letters? Same thing. Okay? This also is a little bit more abstract and it develops a different part of your thinking. Okay? So if you can keep track in your mind, hey, I know that looks really ugly. My gosh, it looks like three variables, T, A, and N. Okay? But they're not. Okay, that thing right here, all of this together, that is a number, and this is another number. Okay? So it's just a different part of stretching your brain there. So if I want to get this by itself, all I have to do is divide both sides by that ugly mess right there, 1 minus tangent 19.9 over tangent 21.8, and this would be the answer. Now grab your calculator. We're going to make sure we're in the right mode. We're in degree mode. I'm going to go to the home screen, and then I'm going to type this in the calculator. Now, would you go ahead and type that into the calculator? This should spit out the right answer. Okay, can I get away with that?
No.
Why not?
We just have the parentheses after the 19.9.
Okay.
You can have an entire parenthesis around the 1 minus 10 tangent.
I need a set of parentheses around this entire bottom, right? Okay, now, that's the major problem on this one. I need a set of parentheses around here because I need to, whoops, that's 1. We're going to insert, there we go. Okay, by putting that, starting the bottom with a set of parentheses and ending with a set of parentheses, we're putting the entire denominator in parentheses. Okay, it wouldn't be a bad idea, although this will produce the correct answer. It's not a bad habit to be in of always putting the entire numerator in parentheses and the entire denominator in parentheses. It'll give you the same answer on this particular one because this is all multiplication. But if there were a plus or minus on the top, you'd want to put that in parentheses. We hit that, and it says round to the nearest, does it say nearest tenth? Nearest meter? Okay, so it'd be about 191 meters. Any questions?
I got it wrong because my calculator wasn't in.
Oh, it was in radian mode? Always want to check that. We go back and forth between degrees and radians, so you want to check that.
It needs to be in radian.
No, it needs to be in degrees.
Okay.
This measurement is in degrees.
Okay.
Yep.
Because I did this all thing 2 times, and I calculated it right, but I kept getting the wrong answer.
At least you're still smiling. Okay. All right. So here's what I'm going to do. You don't have to write this down if you don't want to. Everybody watch, please. Okay. On this one, I'm going to solve this for y, and then I'm going to solve for x, and then I'm going to go back and solve for y, because y is what I'm really after. And the reason I'm going to do that, and I'm going to do this in blue, is if I solve this for y, I get y equals x tangent 21.8 degrees. That's a little easier to deal with. I'm then going to take this and put that on the top. So here's what I get. I get tangent 19.9 equals x tangent 21.8 over x plus 50. Now, if you compare the two of these, I'm at the first step in substitution. This looks a lot better, doesn't it? This just looks easier. Look at this mess right here. I've got a complex fraction and everything. So let's go ahead and solve this. I'm going to multiply both sides by x plus 50. So that's going to be gone. So this is going to be x tangent 19.9 plus 50 tangent 19.9 equals x tangent 21.8. I'm then going to solve this for x, so I'm going to move this to the other side. So I get 50 tangent 19.9 equals, this is going to be x tangent 21.8 minus x tangent 19.9. I still have to factor this, so I'm going to get x tangent 21.8 minus tangent 19.9 equals 50 tangent 19.9. And then to get x by itself, I just divide both sides by that. So I end up with this, tangent 21.8 minus tangent 19.9. And that's what x is. So let's figure out what that is. We'll throw that in the calculator. So this is, let's see, I'm going to put the entire top in parentheses. 50 tangent 19.9. Close the parentheses twice because that's the entire top. Divide that by, well, this denominator is a lot easier. It's just tangent 21.8, close the parentheses, minus tangent 19.9, close the parentheses twice, hit enter. Okay, that's what x is. X is 476.6036. How does that help?
Just plug it back in.
Yeah, here's the cool part. Everybody watching? I can take this, that's what x is, and I can come back here. This is the way substitution always works. If we already solved this one for y, I now know what x is, and I can plug that in. And the cool part is if you've got a calculator, I'm just going to take that answer. I don't even have to write it down. I don't have to round it or anything. I'm just going to take that and I'm going to multiply it by tangent 21.8. So tangent 21.8, making sure we're in what mode, Victoria?
Degree.
Degree mode, thank you very much. Hit enter, and that is the exact same answer. Look, it's still sitting on the screen. It's the same one. Got that? Okay, let me come back here. Okay. Okay, look at the work. This is solving for y directly. This is solving for x and then plugging back in and finding y. So here we never had to know what x was. We just solved the system of equations and figured out what the answer to our problem was. What is y? How tall is this tower? And here we found out, let's see, what did we find out? We found out how far point B was from the tower, and then we used it to find the height of the tower. If you look at that, which one's shorter? Solving for y directly or solving for it indirectly? Finding x first, finding twice as many variables, and then plugging back in and finding the one that we want. I think this one's easier. Quite a bit more straightforward. Now, it doesn't always work that way. It's always good to have two ways to solve a problem. Okay, but that's the way this particular one works out. Okay, you're 9:30, right?
Yeah.
Okay, we'll be out of here in 2 minutes.
Okay.
Okay. Any questions? Okay, so can you solve 45 now?
Yeah, I already solved it.
Nice. Okay. Anything else? Any problems on anything 1.1 through 1.5? Yeah.
So on 18, I couldn't, I couldn't really, it was confusing because we simplified the radical.
So this is 5, this is 1, and we've got alpha right here. So in order to find this leg using the Pythagorean theorem, it would be x squared plus 1 squared equals 5 squared, right?
Yeah.
So this would be x equals square root of 24. So this is going to be 2 square root 6.
But, so on the answers, are you supposed to simplify?
Either way is fine.
Oh, okay.
Either way is fine. Okay? All right. If you have any questions you want to ask me, I'll be in my office. Other than that, I'll see you tomorrow. We'll do 1.6, review on Monday, and test next Wednesday. Okay?